We're told that a student goes to the library and we're asked to let events B equal the student checks out a book and D equals the student checks out a DVD. And this seems familiar. So suppose that the probability of B checking out a book is 0.4, the probability of checking out a DVD, probability of D equals 0.3, and the probability of D given B, the probability of checking out a DVD given that they've checked out a book, is 0.5 or 50%. We're first asked to find the probability of B and D. What's the probability of checking out a book and checking out a DVD? We're going to change things around just a little bit in order to use this tidbit of given information here at the end. Probability of D given B. Probability of checking out a DVD given that the student has checked out a book. In order to utilize that, we're going to say probability of D and B instead of probability of B and D. Means the exact same thing. But that way we can formulaically use the multiplication rule, because then we know that this probability of D and B equals the probability of D given B times the probability of B. The probability of checking out a DVD given that they checked out a book times the probability of checking out a book. D given B we're given as 0.5. Probability of checking out a book is 0.4. 0.5 times 0.4 equals 0.2 or 20%. So the probability of checking out a DVD and checking out a book is 20%. Now what about or? Probability of checking out a book or checking out a DVD. I'm interested to know the complement of that. What's the probability that they go to the library and they don't check out anything? So probability of B or D, we're going to use the addition rule. Probability of B, probability of checking out a book plus the probability of checking out a DVD minus the probability we just found, the probability of B and D, probability of checking out both. So probability of checking out a book we know is 0.4. Probability of checking out a DVD we're given as 0.3. And then we just found the probability of checking out a book and checking out a DVD, which is 0.2 or 20%. So 0.3 plus 0.4, 0.4 plus 0.3 rather, is 0.7 minus 0.2 equals 0.5 or 50%. And like I said, what's amazing about that is that there's a 50% chance they're not going to check out anything. There's a 50% chance they're going to check out a book or a DVD. I guess there could be other items that aren't listed here as well that we're not considering in this problem. Magazines, periodicals, so on and so forth, newspapers. But if we're looking at it in terms of the probability of checking out a book or checking out a DVD, that's going to be 50%.